Another type of asymptote you have is a horizontal asymptote. So a horizontal asymptote is we're looking at the function as x gets really big, so to infinity or to negative infinity. And so the asymptote really only is important when x is really big. And this is a case where, and sometimes you'll see a function where the graph close into 0 might cross the asymptote, but out by infinity it never does. So we're looking at that. So as x approaches infinity or negative infinity, if my function f approaches some number, L is any number, then what we say is y equals L is an asymptote. And what we're having is we call this sometimes end behavior. What happens as x gets really big. So what we're really doing is we're looking at the degrees of the numerator and the denominator. So let's say m is a degree of the numerator and n is the degree of the denominator. So I have like x to the m and x to the n. And remember, the degree is the highest exponent, whatever term it is. So here, what I say is if the degree of the denominator is greater the numerator is greater than the degree of the denominator, then the function goes to infinity. So that example would be something like x cubed over x squared, because when I reduce that, that becomes x, and as x gets really big, it's going to infinity. What if my degrees are equal? Then it goes to some number, any number. So an example would be maybe x squared over x squared. This reduces to 1. So this is going to equal 1. And if the numerator is less than the denominator, it goes to 0. So an example would be x squared over x cubed. As if I can reduce this to 1 over x, and as x gets really big, this goes to 0.